Welcome to week 2 of DataModels. While Blackboard is the official site of the assignments to turn in, the supplemental information is available at CWMclass.com. We're talking about CIT170. It's a 3-credit-hour course, Database Design Fundamentals. Like I said, this is week 2. If you need to reach me, those are the email address and the cell phone. It's better to send an email so that we can coordinate a time that suits both our schedules. If you'll check your announcements for the course each week, I'll tell you what my office hours are for that week. For each week's assignments, and it's a good example. Listing assignments in this presentation and in Blackboard is an example of data redundancy, and that's one of the things that you need to avoid anytime you're working with data. Data redundancy occurs when the same piece of data exists in multiple places. For example, where data inconsistency is when the same question yields different answers from multiple sources. If I have an assignment in the presentation that says that you need to read chapter 2 of the textbook, but on Blackboard the assignment says read chapters 2 and 3 of the textbook, which is correct? This is a classic example of data redundancy. And if you design your data correctly, there's only one place to go to get the answer. This data inconsistency is possible because of data redundancy. We're storing the data on the presentation and then on Blackboard. The right answer is to store it just one place. Okay, so when designing data stores, always store data only one place. Let me say that again. Always store data only one place. Alright, let's say that we want to record the data on country, state, county, and community. Alright, let's think about doing it in a flat file. So we could use a spreadsheet and we'd have a column that's called the country name, the country abbreviation, the country capital, the country chief executive, the state name, the state capital, the state chief executive, the county name, the county seat, the county's chief executive, the community name, and the community chief executive. So in spreadsheets we talk about rows. This would be a header row, and columns. So everything in column A is going to be talking about the county name, the country name. So if we add a row, the first one is going to be United States of America. The United States, it's abbreviated USA, and its country capital is Washington, D.C., and the country's chief executive is Donald Trump. This is recorded in late December 2020. The state name is Kentucky. The state capital is Frankfurt. The state chief executive is Andy Beshear. The county's name is Mason. The county seat is Maysville. The county chief executive is Joe Peffer. The community's name is Maysville. And the community's chief executive is Matt Wallingford. Okay, he's city manager, but for our example, we'll count that. So, all this tells about the information for the chief executive of the community of Maysville, and it tells what county and what state and what country he's in. If we want to talk about another community, we add Dover, but look, we had to rekey the United States of America, we had to rekey the USA, we had to rekey the the country's capital, and I won't repeat all these, but we had to key all this just because we wanted to duplicate a community. Now, we just talked about data duplication. Doing that is a lot of rekeying, and stated another way, we're duplicating data. And remember, the data duplication allows data inconsistency. So, is it Donald Trump or is it Donald Trump? Because we have data duplication, we have data inconsistency. Plus, we've got all this extra effort to key in this stuff when we only really added one value, because it turns out that Dover's so small it doesn't have a chief executive officer, or if it does, it doesn't in this example at least. So let's start with, how can we sort based on the last name of the country's chief executive? Well, we can't. We're going to talk about atomic data. It's information that can't be broken down to smaller parts. The term is often applied to the source of data that hasn't been calculated but is instead consists of concrete business reality. For example, an example of poor data organization is to have name of chief executive Tom Leader. The problem is you can't sort on leader because you don't have any easy way to find it. An example of good organization would be to have first name field Thomas, last name field Leader. So to change our data set, we would have two columns instead of one, and we would have the county chief executive first name, the country chief executive first name, Donald, country chief executive last name, Trump. Now, we've still got lots of data duplication, but as with anything else, we're trying to solve one problem at a time. If you try to solve all the problems on this page at once, you won't get any place. So we're going to divide and conquer. And the first thing we're going to conquer is to divide the country chief executive name into two parts. And sometimes you'll have people who divide it into three because they'll want to support a middle name. And if you were going to do this, and I'm not going to take you through it, but you would repeat that process again over here on the county's chief executive, on the state chief executive, and on the community chief executive, so that you would add two fields here and so forth. Addresses are another example of things that are often not separated but should be. So if you see a mailing address for the chief executive that's all one string along thing, you can know that you've got somebody who doesn't understand data. The problem is you can't support, if you want to sort in city order or in zip code order, you can't find it because it's out here in the middle of this long string. A better solution is to have an address, or maybe address 1, address 2, 1606 Pennsylvania Avenue, the city of Washington, the state, or D.C., it's not really a state, but you understand what I'm saying, and then a zip code. Again, we've divided this concatenation of several things put together into each individual. The other problem you need to worry about is calculated data. People will often say, well, I'm going to store three values. I'm going to store the quantity on the line, the price of each unit, and then I'm going to store the extended. Well, what do we see as a problem here? On what planet is 2 times 4, 7? Don't store 7. Don't store calculated results. Instead, store the components that are used in the formula and calculate the result. That way, you can tie, this value will always be accurate. Now, as in almost everything, all broad generalizations are false. So I had a company where we had the people who were taking orders had the ability to override the extended value of a line because we trusted them enough that we knew that if they came up and decided that we ought to charge less for this gearbox, they could mark it down. And in that case, it's not really a calculated value. You get the first cut with a calculation, but then somebody has the value. So the point is, anytime you have a value that can be calculated, you probably shouldn't be storing it. But to make these kind of decisions, you need to understand the data and what it does and why it does it. And that's why on your class projects, we're going to ask you to come up with a business case, define those kind of things about what your data needs are, and then we'll check to see if your database enforces it. All right. It's easy to do complex. It's not easy to do simple, but what we hope to teach you is how to take a complex world and find ways to simplify it. All right, one of the things we said is consider storing information on government organizations. And remember, we said we had nation, state, country, and community. Well, we had it all on one spreadsheet, and we solved the problem of having to rekey so much stuff. Let's think of pools of data. These columns are really all that we need to keep up with the country pool. Then we've got these columns that are really the state pool. These columns are the county pool. And these are the community pool. Now let's see if we can, by dealing it with each separate pool of data, make it easier. So in our spreadsheet, it would have looked like that. In a spreadsheet, we talk about a spreadsheet file, and when you open up Excel, it has tabs, and the tabs have row and columns that we pointed out to you. A file or a table, we've said that a file in the physical world is a collection of all the data we want to store about one thing. For example, our recipe cards that we talked about last week. Now, in a computer database, we're going to spread it across two structures, and we call each of those a table. A table is a row of data called a record, and that row of record is divided into fields. In a database, we are not sure how data is stored, so we avoid using the word file because that has a specific meaning in different operating systems, and so we don't want to use that word to avoid confusion. All right, so we've talked about a spreadsheet or a flat file, spreadsheet, tab, row, column. In a database, we're going to talk about that we have tables. Tables have records, and then records are divided into fields. Data models we use for conceptual data design to help us visualize the data and its relationships. We talk about entity relationship diagrams, or ERD, is a common example. In those, we have models, entities, and attributes. But an attribute is simply a field, which would be a column in your spreadsheet. Because this is a model, we really don't have rows because that's actual data. We're just modeling. This is like the structure you would put it into, where a tab would be called a table in a database. In a model, it's called an entity. And there's some other names floating around out there, but the concepts are the same. All right. We talked about trying to divide that spreadsheet up, so we said that we're going to gather all the data that has only one value to store at a time. And so for nation, beside the country name or nation name, I'm going to put a country ID, which is the primary key, and I'm going to use a number. And I always try to use a number for my primary keys, or all broad generalizations are false, and so that's a false statement. Most of the time, I use a number for the primary key because I can store more information in a smaller area with a number, and because I don't have to worry about cases or spaces or all that sort of trouble. So the first two fields I'm going to have in my country table are the country ID and the country name. Uh, and when we think about what we saw on that country columns, we had name, abbreviation, capital, CEO's first name, and CEO's last name. And each nation has one and only one name, and one abbreviation, and one capital, and one CEO first and last name at any given time. And so we could represent that in our ERD data model by this. That's the name of the table, the primary key, and then the fields that I have in it. And next week we'll learn more about ERDs and so forth. All attributes with a one-to-one should almost always be in the same table. And there's mathematical logic that says if every country ID has one and only one country name, and every country abbreviation has, every country ID has one and only one country abbreviation, these two are one-to-one, then these two must be, every country name must have only one country abbreviation, and so forth. So all these one-to-ones you want to group together, just because it makes it easier to get to anything you want about the country that's one and only, every country has one and only one, put them in the same value, in the same table. So all attributes with a one-to-one relationship should almost always be in the same table. A one-to-many. A nation has many states. To avoid duplication, we're going to store the state table in a different information. So the column state name, state capital, state chief executive, we're going to store in a table called state, and it has a state ID, which is an auto-generated number, primary key, these values, these field names. And if we draw how they're related, we say that we can get from the country to the state based on a country ID. So we have a relationship of country ID to country ID. That means that no matter how many states you have for the United States of America, you only have to update the country CEO's first and last name one place, and all the states will come across this relationship and pick up that value. When we talk about one-to-manys, watch for hidden one-to-manys. I said to you that every country has one and only one chief executive. Well, that's right at the current time, but the CEO's last and first name will be different on February. The U.S. CEO or president's last name will be different on February the 21 and on December 2020. So, do we need to store only the current CEO's last name, the current president? If so, this organization, well, and we're going to by that time have made it first and last name, but only having, keeping it on this row will work. Or do we need to keep up with all the different presidents we've had through time so that we can find out what it is today in February 2021, and we can look back and see what it was in December 2020 and who it was before that? If you have more than one CEO's name, that you will have one nation, but may have many CEO's last name values. Okay, so what I'm trying to say is, if we're trying to keep multiples, we're now into a one-to-many. So how do we tell which is which? And this is, again, where thinking about your data as you come up with your class project directs this. There's no right answer. All database design is an art form that's basically trade-offs. So you can say, well, I'm going to keep it based on year. Who was it in 2020? Who was it in 2021? Well, the problem with using year is that you have the CEO change in January. So year really doesn't work very well. The other problem with year is that you have somebody like Harry Truman who didn't hold the whole term. I mean, if you put in it every year, when Harry Truman took over for Franklin Delano Roosevelt, who would you put in? If you say, well, I'm only going to load December 31st, who's the president on December 31st? Well, then, for Mr. Trump has been president on 2016, 2017, 2018, and 2020 on December the 31st. Well, we're keying 4 values and we're having redundant data again. So I really don't like that very much. Another way is to say, well, I'm going to keep up with each CEO, and if I have 2 CEOs in a year, I'll be able to support that. And if I go 8 years, or in Roosevelt's case, almost he went 12 and starting on year 13, you'd only have 1 entry for him. So I like that because I'm not duplicating data. So our original table country looked like this. And what I'm suggesting is that we have a nation CEO table that says, so we got a primary key that's an automatic generated number, and we're going to tie it back to a country. We're going to have a sworn-in date, so every time we swear in a new chief executive, we'll add a record and put in a new sworn-in date for the United States of America, and we'll put the CEO's first and last name in. Okay, well, if we use that solution, can we tell if a person was the country's CEO more than once? I think it was Cleveland that was elected and then lost an election and came back and run again. You really can't, because we can't be sure that it's going to be Grover Cleveland spelled the same way both times. Will it be G.C. Cleveland? So that really could break down when you try to figure out how many times the same person has been president. So it won't do it. All right, because of the variations in CEO names, like we said. All right, so if we had a country table and a CEO name table, and this is called an intersection table, so that we say link to the CEO, link to the CEO ID, link to the country, and have a sworn-in date. Because we're getting the CEO's name out of this table, we can be sure that we don't duplicate. And now we'll be able to tell if the same person has been president more than once, or like Cleveland. All right, but we still have got the same issue over here on state. So a way to solve that would be to do the same thing. You still have CEO names, one table for all the different CEO names, and you link to either if they're a national CEO or a state, and we could link it to counties and to cities. So if you had somebody like Franklin Delano Roosevelt that was the governor of a state and later was the president, you'd be able to tell that how many people had been both president and a state officer. Because of the art form, data models can help us do high-level conceptual data evaluation, so we can visualize, talk to the users, and try to see if we've thought of all the different things that the people may want to pull out of it. The record-based logical data models talk about how we're going to store and access the data in the computer. These types of issues drive database design. If you use data, you need to understand them and consider them when you have other design how to store when you have others design how to store your data. So I don't really care whether you say I'm never going to design a database. Well, if you're using spreadsheets or talking to people who are designing databases for you, you need to understand there are trade-offs. And when they say, well, you can't do that, be smart to say, well, we could use an intersection table to do that, because the truth is you can make a computer do almost anything except have human emotions. If you're the designer, on the hand, you need to consider them when you design and how to store your data yourself, but you also need to be able to use these kind of models to communicate with your users to make sure that, oh, you only want to know the current president. Well, we don't need that overhead of keeping up with all the historical presidents. Oh, you need to know who was the president before or the salesman in that territory before. Well, there's ways to solve either problem. Both come with costs, and using the models you can help reach consensus on what's the best value. Classifications based on database distribution. We have the centralized system. This is the old mainframe model, where there was a computer or a glass room someplace, and all the users are running basically dumb terminals back to them. And the interesting thing is that many of the modern websites are much like the old mainframe terminal. We have distributed database systems. This is where you have a database on 3 different continents maybe, or 3 different towns, or 3 different buildings that are all exchanging data all the time. I worked for Stober Drives, and we had a database in Maysville, Kentucky, and we had databases in Pforzheim, Germany, and they had one in Yugoslavia. They were all strapped together so that we were updating all the time. You can have a homogeneous distributed database system, which is the same database manufacturing software at multiple sites. And you can have a heterogeneous distributed database system, which is different sites may use different database management software, but there is an additional common software to support data exchange between these sites. And a company like Emerson was an example of that, where they had bought, Emerson Power Transmission bought, I don't know, many different companies. And each time they'd buy a company, that company would come with a computer system. And so they had to figure out a way to get it so that all the different computer systems could consolidate and roll data up to the division. All right, some more terms. Relation is a link between tables. One of the things to remember is you really only need one relation between each table. So if you have a state and have this country ID to country ID, you can go across and pick up all these different values, but you really only need to have one relationship, one to many. Because if these are all 1-to-1 and these are all 1-to-1, then any of these can use this relationship between the country ID and the country ID to bridge that between those 2 tables. A word that you will learn to hate is Cartesian product. And sadly, many of the selects that you'll do, if you're not careful, well, all the selects you will do, and what you do is learn over time how to defeat the problems of Cartesian product. But a Cartesian product says that every row of table 1 will be matched with every row of table 2. So this is a way that you can make a computer simulate sleep, because if you have this data set where table 1 has 5 values and table 2 only has 2 values, if you look at the possible values from just these, looking at table 1, row 1 and row 2, you're going to have 1A, 2A, 3A, and so forth, all the way to 5A, and then you're going to do 1B to 5B, and then you can start to see if this is 1 million and this is 10 million, you really make the computer thrash a bunch but that's how databases work on selects. And so There's much time figured out how to use indexes and so forth to avoid Cartesian products or to not die because of them. So synonyms, we talk about relations, tables or files, tuples, rows or records, attribute, a column or a field. And not that you need to remember those, but just don't freak out if somebody starts talking to you about tuples. What they're really talking to you about is a row or a record. All right, an example of a database project. This is Miss Garrison's. Provide a database system that will help a small bakery business track customers, orders, and menu items. And you ought to be able to say it in a sentence or two. And we now know what's got to be done. And we want to provide a user-friendly main menu, data entry forms, queries, and reports. Now the truth is, for almost all of your database projects, that's going to be the same. This is where the action is. That's what you need to be working on right now, because if you get that clearly stated and understand what it is you're trying to do, your project will be a lot easier. It is a true statement that if you don't know where you're going, it's hard to set course to get there. Alright, in week 3 we're going to start using Access. It's part of your student version of Office 365, so you will not have to purchase a copy. When you complete week 2, you'll need to be sure that you have Access available on your computer. If you have problems, send me an email at cmarshall0050@kctcs.edu and we can try to figure out how to get it so you can use it, because you've got to have access. And we're soon going to be using a free version of the Toad Data Modeler. This will be creating the ERD data models, and it makes it fairly easy. I want you to be sure and use the trial version that does not expire. It's good to load it on your computer, and I'm going to show you now how you get to that. If we're on the Blackboard and we come down to CIT ebooks and software, we come down to the Toad Data Modeler software. I want you to download it from there. There are versions out on the internet that are quote free, but they're only free for 30 days. Now, I will confess to you that the version we've got that works without running out of time, and there's nothing worse than your class project due Monday and your software expires. If you use this one, you will not be able to export your model and build a basic Access database. You'll have to use the model and key it by hand into Access. My experience is that doesn't take long. We're talking about you're going to have 5 to 10 tables or something, and not that many fields, and I think that's the way to go. If, on the other hand, you wanted to go to CWM class, you can go to the course resources and roll down, and there's where you can download the software. And we've got videos to introduce using it if you want to start reviewing it before we actually get to it.